Hello my kiddos, this is me, Miss Ellen again, and today we're going to be practicing solving for force, mass, and acceleration using the three-step process. So what is the three-step process? The three-step process is nothing but, like it says, a three-step process that helps us to solve, in this case, force, mass, acceleration. But in the near future, you're also going to see us using the same three-step process for other type of calculations in our science class. So the first step, you're always going to circle, or you can label, provided information. The second step, you're going to write out the formula and you're going to plug in information. And then finally, once you do step 1 and step 2, I want to see you solving the problem, okay? And everything I'm doing, I want you to do on your end as well. So the first practice problem, it says, example number 1. How much force is needed to accelerate a 66 kilogram skier at 2 meters per second squared? Now the first thing I ask myself is, what is the question's asking? I see that the question's asking us for force. So according to my three-step process, I'm going to start circling and labeling the provided information. They're asking us for force, so I'm going to put a little question mark around here. How much force is needed to accelerate a 66 kilogram? I see kilogram, so in my head, I know that this is going to be dealing with mass. Kilograms, 66 kilogram skier at 2 meters per second. That right there, you guys, sound like acceleration to me, so I'm going to label that with an A. Now, we're going to write all of this out. So we are looking for force, so I'm going to put an F, put a question mark, because that's what we're going to be solving for. They have provided us with mass, 66 kilograms. They have also provided us with acceleration, which is 2 meters per second squared. Now, second step of our three-step process, we're going to write out the information and we're going to plug it in. So, with that being said, we forgot one more thing. Do not forget to always write out your triangle, your tricky triangle that helps us solve these problems. And if you've done the assignment before, this is something familiar that you have already seen. So you know it just helps us to solve the problems. So you have force, you have mass, and you have acceleration. So I'm looking for force. What I'm going to do, I'm going to cover up the force with my finger. Basically, this is telling me that in order to find force, I need to multiply mass times acceleration. And that is exactly what we are going to do. So force equals mass times acceleration. Now we're going to plug it in. We are looking for force. I'm going to keep that blank until we solve it. Mass is 66 kilograms. Times acceleration, which is 2 meters per second squared. Take out your calculator. In our case, we're using our Chromebooks, or if you have a calculator at home, you're more than welcome to use it. 66 times 2 is going to give us 132. What is our unit of measurement? We're going to bring down the kilogram, because we're looking for force, along with meters per second squared, and that is our force. And if you remember from the notes that we've taken before this, kilograms per meter squared is the same thing as 1 Newton. So do not forget that. So even though we're writing out kilogram per meters per meter second squared, it's basically the same thing as saying 1 Newton. And let's go ahead and put a box around our answer. So example number 2 states that a force of 250 newtons is applied to an object that accelerates at a rate of 5 meters per second squared. What is the mass of the object? According to our three-step process, we're first going to circle or label the provided information. So let's get to it. A force of 250 newtons They're telling you what it is, so this got to be our force. And yes, I could have put capital F for short. Is applied to an object that accelerates at a rate of 5 meters per second. Sounds like this is our acceleration right here. What is the mass? Here's our question. Put a little question mark around it. What is our mass of the object? So now that we have circled and labeled the provided information, now we're going to write out the formula and we're going to plug it in. First things first, I'm going to write out what we have. We have force, which is 250 newtons. We have acceleration, which is 5 meters per second squared. And of course, we're looking for mass. Before I solve my problem, I want to write out my fancy triangle that always helps me and never lets me get any problem wrong. That's going to be force, mass, and acceleration. We're looking for mass, so I'm going to take my finger and I'm going to cover up the M. And if you can see, according to the triangle, in order to find mass, we are going to divide force divided by acceleration. Again, force divided by acceleration equals mass. So let's write that out. Mass equals force divided by acceleration. Let's, according to our formula, we wrote it out. Now let's start plugging it in. So we have force was equal to 250 newtons divided by acceleration, which is 5 meters per second squared. Now before we divide, we cannot divide with this Newton sitting right here. We first have to convert that. And according to our notes before, Newton is the same thing as saying kilograms per meter second squared. So I'm just going to cross out that N and I'm going to write kilogram per meter second squared. Now we can divide. I see that I have meters per second, so I'm going to cross that out. That leaves us with kilograms, and because we're solving for mass, kilograms sounds about right. So 250 divided by 5 is going to leave us with 50. What is our unit of measurement? We canceled out the meters per second on both ends. That leaves us with kilograms. And like I said, because we're solving for mass, the unit of measurement has to be kilograms. So this sounds about right. We are now on example number 3. So, if a 60 kilogram person on a 15 kilogram sled is pushed with a force of 300 newtons, what will be the person's acceleration? Again, we're following our handy dandy 3-step process. We're going to start off by circling or labeling the provided information. I see that we have 60 kilograms. I know that is mass. I also see 15 kilograms on this side. That is also mass. I see 300 newtons. Sounds like force to me. Let me draw a little arrow so I know which one I'm applying to. And what will be this person's acceleration? Find out what we are looking for. So now what we're going to do, we're going to write out our formula because that is the second step of our 3-step process. So let's write it out. We have mass and we have 2 mass. So this one might be a little bit tricky. Let's see what we get. So we have 60 kilograms, right? But they gave us 2 this time. Why did they give us 2? So let's reread the problem to fully understand. So it says if a 60 kilogram person on a 15 kilogram sled is pushed. So these two, the person and the sled, is both being pushed with a force of 300 newtons, what would be the person's acceleration? How fast will that person be going? So if I'm pushing a person who has a mass of 60 kilograms, they're also sitting on a sled that weighs, that has a mass of 15 kilograms. I'm going to be pushing both of them, right? Both of them at the same time. So that means I need to combine them. So that's going to be 60 kilograms. I'm going to add that on to 15 kilograms. Because the problem didn't say that one person pushed a person and then the other person pushed a kilogram. They said if a 60 kilogram person who's sitting on a 15 kilogram sled is pushed with a force of 300 newtons, what would be the person's acceleration? So that means I need to first get the combination, the total of the mass. So 60 plus 15 is equal to 75. Let me add my unit of measurement, kilograms. The force is 300 newtons. And they want to know what will be the person's acceleration, right? That's going to be our question mark. So with that being said, before we start, let's write out our handy dandy triangle again. And I want you to do this every single time, you guys. So I have force, mass, and acceleration. Because they're asking for acceleration, I'm going to cover that up with my thumb. By doing so, the triangle lets me know that in order to find acceleration, I need to divide force divided by mass. So we're going to write that out. So acceleration is equal to force divided by mass. Now, step 3, now that we've written out everything, we have plugged in everything, now we are going to solve. So force is 300 newtons divided by the mass, which is a total of 75 kilograms. Don't forget, this Newton, we cannot divide like that with the conversion, with the unit of measurements not being the same. We need to convert it first, right? And according to our notes, we know that 1 Newton is equal to 1 kilogram per meter second squared. So I'm going to convert that out just to like it says right here. Kilogram per meter second squared. So cross this out real quick and I'm just going to convert it. Kilogram per meter second squared. I have 2 kilograms. I'm going to cancel that out. Let me use my red marker so it's a little bit easier to see. And that leaves me with meters per second squared. We're solving for acceleration, so being left with meters per second squared is perfect. 300 divided by 75 is going to give us an acceleration of 4 meters per second squared. And we are almost done. One more example. Example number 4. A 5 kilogram block is pulled across a table by a horizontal force of 40 newtons with a frictional force of 8 newtons opposing, look at that fancy word, opposing the motion. Calculate the acceleration of the object. 3-step process again. We're going to circle and label the provided information. So I see 5 kilograms. By this time, you should know that this is mass. A 5 kilogram block is pulled across a table by a horizontal force of 40 newtons. So here's our force. With a frictional force. So we've talked about friction before, right? I'm going to underline that because that stands out to me. A frictional force of 8 newtons opposing the motion. Calculate the acceleration of the object. Here is our problem or question. That's what we're solving for. So first, next thing we're going to do, we are going to write everything out. So they provided us with mass. And we know that our mass is equal to 5 kilograms. They've also provided us with force. But they gave us an opposing force as well. So it says right here, a 5 kilogram block is pulled across a table with a horizontal force of 40 newtons, right? So let's write that out. However, it is being pulled with a frictional force of 8 newtons. And if we learned this earlier this week, we know that friction is anything that is a resistance, right? It works against force. So if it's working against the force, what do you think I need to do with this 8 and this 40? And if you guessed it, you know that we should most likely subtract because it is resisting. So that's going to be 40 minus 8, which is equal to 32 newtons. And then it says calculate the acceleration. That is what we're looking for. So I'm going to put an A and a question mark. Before I get started, I do not want to move on unless I write out my fancy triangle each and every time. The question is asking us for acceleration. If I cover up acceleration with my thumb, I see that in order to solve acceleration, I have to divide force divided by the mass. So let's write that out. Acceleration. Oops, when did I switch to brown? Acceleration is equal to, let's make sure, force divided by mass, right? So let's plug it in. Force is 32 newtons divided by our mass of 5 kilograms. Of course, we're going to divide, but before we divide, you know that we cannot work with that newton in that kilogram. We first need to convert that newton. And as we have in our notes, we know that 1 newton is equal to 1 kilogram per meter second squared. So I'm just going to rearrange that real quick. Kilogram per meter second squared. Now that my conversions are the same, I see that both kilograms cancel each other out. I'm left with meters per second squared. That makes sense because we're dealing with acceleration. 32 divided by 5 is going to give us a decimal, still a number, of 6.4. Remember, we're working with acceleration, meters per second squared. Here is our answer, you guys. Super easy. Do not forget, make sure you reread word problems, you guys. So if you saw as I was doing with you, I reread each word problems multiple times as I needed to until I fully understood what the question was asking. I labeled every single thing every time. I wrote my handy dandy triangle every single time, and everything I do, I want you to do as well. So with that being said, go ahead and copy each of these 4 examples down, word problems, including of course the word problems and including the notes and the diagram. Go ahead and continue on to part 2 of this assignment. Talk to you later, my kiddos.